Now you may have been wondering, what do I do to complete the square and then map the vertex form of something that looks like this? Negative x squared, this is number 3 from the homework for C and E block. Negative x squared minus 14x minus 59, where my lead coefficient isn't just a plain old 1. Well, I'm going to do a video on how to do that for you. Before we do anything, though, I want to remind you what the vertex form looks like. Remember, thanks to the mathwarehouse.com, I found this nice little image. The vertex at HK right here is y equals a times x minus h squared plus k, where the vertex is at HK. That's vertex form. Then there's something called standard form, which is the form you've been more familiar with, ax squared plus bx plus c. And then there's another form that you've seen, which is factored form, where you've got x plus something times x minus something. There's a couple of binomials in parentheses. But right now we're going to be dealing with going from standard form to vertex form so that we can graph our parabolas by taking advantage of the vertex, which is going to be at HK, whatever HK happens to be. So let's take a look at this one. My first thing I'm going to do, before I do any shenanigans with completion of the square, is I am going to figure out what the y-intercept is. Now I have this equation, and the y-intercept is when what y is when x is 0. Well, when x is 0, negative x squared is just 0, so I don't care about that. And negative 14x is also 0. So y is negative 59. That's all that's left over after I wiped out all those x's by turning them into zeros, and that wiped out all the x terms as well. So y is negative 59. The y-intercept is at 0, comma, negative 59. We'll come back to that when we're getting the mirror point. Now, we're going to have to complete the square in order to get the vertex form. Get rid of that automatic numbering that's going in there. So here we go. So the first thing I want to do is I want to put parentheses around this business. So negative x squared minus 14x minus 59. Now my next thing I'm going to want to do is I want to get any shenanigans that are in front of this x squared out of here. So I am going to factor out negative 1, because that negative represents a negative 1. So I'm going to put a negative 1 here. I factored it out of both of them, so both of them change signs. So I divided negative x squared by negative 1 and negative 14x by negative 1, which left them both positive. So I factored it out of both of them. Remember, you have to factor it out of both of them. I have done nothing that changes this equation, this side of the equation at this point, but I'm about to. What I need to do is I need to come up with something that I could add, another term that I could plug in here to x squared plus 14x to make that a perfect square. And the way I'm going to do that is since there's no coefficient here, I'm going to divide 14x by 2x. And then I'll know what I'm squaring and adding to the end of this. So 14x divided by 2x, because remember, this is my 2ab, and I just want b, so I divide by 2, and then I divide by a, which is x, since a squared is x squared. So 14x divided by 2x is going to equal 7. So my b is 7, so what I need to add here is 7 squared to make that my b squared. But 7 squared is 49, so I'll add 49. Okay, in the past, what we've ended up doing at this point is, since we added a number here, we subtracted a number here. But I'm not really adding 49 because this whole business here is actually times negative 1. So I'm adding negative 49. So over here, so that means like I'm really subtracting by 49. So over here, I'm going to subtract. This is a way to keep track of this. I'm going to subtract negative 1 times 49, which is going to be the same as subtracting negative 49, which is going to be the same thing as adding 49. So since this is a negative piece of this, when I add this, it's really subtracting it, which means I then have to add it. So subtract 49 over here, add 49 over here. The reason for doing that is so that I am really just adding 0 to this side of the equation, so it doesn't make it no longer an equation. I have to keep both sides equal. And I can't do that if I add something to one side, not the other. I'm not adding anything over here because that just muddies the water. So this is what I'm left with. Looked like adding 49, but it was really subtracting 49. So when I subtracted 49, I had to add 49. So now we can simplify. Negative 59 plus 49 simplifies to negative 10. And then this part here becomes negative 1 times a perfect square. That's going to be x plus 7 squared. Oops. And now I have my vertex. I can find my vertex from this. So x minus h, this is x minus negative 7. So this is going to be a negative 7 for my h, negative 7, comma, and that's plus k, which, and this is plus negative 10. So my k, my vertical transformer, is negative 10. So I have a vertex at negative 7, negative 10. All right. Now that I have my vertex, I can go ahead and get my mirror point. I don't know what my y value is, my x value is for that yet, but I know my y value is the same as my y-intercept because it's the opposite side of a symmetrical parabola. Okay, so to get from 0.59 to halfway across the parabola, I have to go negative 7 horizontally. And I need to get to the other side, so if halfway across is negative 7, all the way across is another negative 7. So if I do negative 7 and another negative 7, it's negative 14. And that is my other point on the other side. At this point, I need to select a couple of points. And I'm going to find it easier to plug in x value inputs to the vertex form. So I'll just copy that here a couple of times. And we'll pick 2 points on either side of negative 7, because that is my middle point, and I would like to have 2 points that help with the symmetry of things. So I'm negative 7 to 0, negative 7 to negative 14. Let's pick a number that's right in the middle of all of that. So halfway from negative 7 to 0 would be negative 3.5, but I don't like that because it's got decimals. So I'm going to choose a different x value. I'm going to choose negative, we'll choose negative 4. And the other point will be, and that's 3 away from negative 7. I'm going to get something that's 3 away on the other side. 3 on the other side of negative 7 is negative 10. Okay, so I now am looking for y values that these two x values make. So if I replace x with negative 4 here and negative 10, you can predict both of these will produce the same result, but let's go ahead and do the math. So this is using negative 4 as my input. So negative 4 plus 7 is 3. So that becomes 3 squared, and 3 squared is 9. And then negative 1 times 9 is negative 9, and negative 9 minus 10 is negative 19. Okay, let's try that here. So negative 10 plus 7 is negative 3. Negative 3 squared, or negative 3 times negative 3, is 9. 9 times negative 1 is negative 9. And then I've got negative 9 minus 10, which again equals negative 19. So my two more points are at negative 4, negative 19, and negative 10, negative 19. And we can go ahead and plug them into the graph and see what it looks like. So I'll start with my vertex at negative 7, comma, what it was, negative 7, comma, negative 10. And I'll add in my y-intercept at 0, comma, negative 59. And my mirror point to my y-intercept on the opposite side of that vertex, negative 14, negative 59. And then I'm going to go and remind myself what my other 2 points were, negative 4, negative 19, and negative 10, negative 19. So negative 4, negative 19, and negative 10, comma, negative 19. And let's zoom out so you can see these points. You'll see something interesting about this parabola. This parabola is pointing downwards. So let's plot our actual parabola. That was, go back to the original thing. It was y equals negative x squared minus 14x minus 59. And there it is. It matches. Okay. I don't know what that is doing on my screen, but I'll move out of the way. Okay. So here we go. That is our parabola. And now we're going to do it one other way. I believe this extra artifact on my screen has to do with me having too many tabs open. Well, there we go. All right, so I'm going to turn that off. I'm going to turn that off, and we're going to graph this using the other way. Okay, we're going to use the vertex point that we've got. And then if you remember, there's a pattern that we could use for graphing a parabola. Okay, so if I use my vertex at the center, now the thing we got to remember is that my a value, whether it's in standard form or it's in vertex form, was negative 1. So that changes things. I am going to plot negative 7, negative 10. It changes things in one key way. Instead of going over 1 and then up 1, I'm just going to reverse it. I'm going to go over 1 and down 1, over 1 and down 1, and from there over 1 and down 3, over 1 and down 5, and so forth. So let's go ahead and come up with some points that work like that. So my next point is going to be over 1, so negative 6, and I'm going to go down 1 from negative 10, so negative 11. Okay, and then I'll plot on the other side of negative 7, negative 8, comma, negative 11 as well. You can see it starting to show up. And now I will go over one more from negative 6, one more out from my center, from negative 6, and one more out from negative 8. So I'll have negative 5. And this time I'm going to go 3 down from negative 11 to negative 14. And I'm going to go in the same other direction with negative 9, negative 14. And I'll go one more. This time, instead of going up 5, I'm going to go down 5. So it's down 1, down 3, down 5, down 7. So I'm going to have negative 4. I'm going one further out from negative 5. And then I'm going to have 5 down from negative 14, so negative 19. And then on the other side, I'm going to have negative 10. And you may remember these were points that we'd already found. And now we will plot our original equation and see if it matches. And it does. So using the pattern, paying attention to how the pattern of how a parabola looks, and then scaling it according to our A value can save you a lot of time. Now, I'm going to do number 4 as well. Number 4 has a lead coefficient of 2. So we'll start off by getting our y-intercept. And our y-intercept is going to be what y is when x is 0. So I'll plot that there. I'll write that down there. And if x is 0, 2x squared is nothing. So go away 2x squared. And 36x is nothing as well. So go away 36x. So y is 170 when x is 0. So we have a point at 0, 170. All right, cool. Now we can get into the act of completing the square. And I'll get rid of my automatic paging again. And this will allow us to get our vertex. I'll start off by grouping the x terms. And grouping the x terms, then I'm going to be trying to come up with a perfect square. Now, before I can start with that, I really want this lead coefficient to be 1. So I'm going to factor 2 out of everything. So copy that there. And get rid of the random tab that showed up. Okay, so now I'm going to factor a 2 out of both of these terms. So this is going to become just x squared, and this is going to become 18x because I'm factoring 2 out of it as well. So I'll write the 2 there, and then I'll adjust these accordingly. Okay, so that became x squared and 18x. This is still 170. Haven't changed anything about the equation. I've just moved a factor of 2 out of here, and it's still there. It's multiplied times that stuff. Now I need to get a term I can add to x squared plus 18x that makes this a perfect square, and that term is going to be from my 18x. I'm going to divide 18x by 2x, and I do that, I get 9. And so my last term is going to be 9 squared, and that gives me a perfect square structure. I'll go ahead and write that as 81, but I'll not have it be an exponent. There we go. So it's 81. So I've added 81 here, but have I really added 81? No, I've added 2 times 81 here, which means I've really added 162. So over here, I'm going to have to subtract 2 times 81 from that side to make sure that I haven't actually changed anything. I've added 162 and I've subtracted 162 here. So really I've only added 0. So I'll simplify that and make that minus 162. And now I can further simplify this. This becomes 8. 170 minus 162 is 8. I know my y value at my vertex is 8. And x squared plus 18x plus 81 is x plus 9 squared. So now I have my vertex form, and my vertex is negative 9, positive 8. That is my middle of my parabola. And now I have that. I'm about to get visited by my son, so we'll pause. Okay, we're back for a few minutes until I get visited again. But where we were was we found the vertex at negative 9, 8. And we also knew that we had a y-intercept at 0, 170. Now, we just need to figure out the mirror to the y-intercept? Well, the y value for that is going to be 170. And then we're going to have to go -9 to the middle and another -9 to the other side. So there we are. We have our mirror point. I'm going to take a little pause again. Okay, we were just talking about the mirror point and the which is at -18, 170, the vertex, which is -9, 8, and our y-intercept at 0, 170. So we're going to want to get 2 more points, and those 2 points, I'm going to pick something between 0 and -9, and -9 and -18. I'm going to pick something that's the same distance from the vertex on either side. So let's see. Let's pick about halfway from -9 to 18 is going to be, we'll say -5, and so -5 is 4 away, and we'll also pick -5, and we will also pick something on the other side of -9, which is going to be 4 away, -13. And then we'll have to go ahead and plug in those inputs for the into the function and see what the output is. Okay, and we are back. So we have 2 more points. We want to use our function to get the outputs for these inputs. So I'm going to scroll down a little so we can see what the heck we're doing. I'll just do it this way. Put that one there and this one here. So -5, we're going to plop that in there for x, -5. And -13, we'll plop that in as the input replacement for x. And we'll see what these work out to be. So -5 plus 9 is 4. That's 4. And -13 plus 9 is -4. Okay, so we got 4 squared and -4 squared. Well, 4 squared is going to get us 16. So I've got 2 times 16 there. And -4 squared is also going to get us 16. So I get 2 times 16 here, 2 times 16 there. And that's just going to become 32 and 32. And 32 plus 8 equals 40. And it still equals 40 here. Okay, this tells me I have points at -5, 40, and -13, 40. Let's go ahead and plot all these points. We got a vertex at -9, 8. Turn all this business off. We'll start here again. So we got a point at -9, 8. Okay, and that's not currently visible. So I'm going to move it so it is -9, 8. I know that I have a point at 0, 170. Can't see that one right now, so we'll shrink ink this so you can. It's way up there. I'm gonna leave it like that. Okay. And then we have a point on the other side of our vertex at -18, 170. And then we have points at -5, 40, and -13, 40. And now we're going to plot that parabola. And that parabola is, let's go up and find that parabola. Here it is. Y equals 2x squared plus 36x plus 170. Let me fix the format here. And it goes right through all those points. That's fantastic news. However, there is a sneaky, easier way to do this. We're going to use the vertex point for this and the fact that it's a 2 as our coefficient, which means we're going to be doubling our pattern, that 1, 3, 5, 7, 9 pattern, and it's to become a 2, 6, 10, 14, 18 kind of pattern. So we're going to go down here and we're going to plot this. I'm going to zoom in back in and we'll zoom out a little bit. And we're going to plot this point -9, comma 8, which was our vertex. Now, I'm going to be going, I'm going to zoom in a little more than that so we can see our stuff here. So I'm going to be, and we're upward, so I'm going to move this down to the bottom since this vertex is at the bottom of our parabola. So instead of using the pattern of going over 1, up 1, and over another 1, up 3, we're going to double the up part of that pattern because 2 means doubling. So we're going to go over 1, up 2. So we're going to go up. So we're at -9. We're going to go over to -8. And we're going to go up from 8 to 10. So here we go. -8, comma 10. And we'll go on the other side of it, -10, comma 10. And you can see it's already starting to have that little parabola shape. And now we will go over one more to -7. And instead of going up 3 from 10, we're going to go up 6. So 16. We're doubling that pattern. And on the other side, it's going to go -11, comma 16. And then we'll go ahead and instead of going up 5, so we go 1, 3, 5, we'll go 2, 6, 10. So now we're going to go to -6 up to 26. Can't see it here, but now you can. And then we'll also go to, scroll all the way over here. And then we're going to go to -12, comma 26. And let's see if that matches our parabola. It totally does. It goes right through it just fine. So using that sneaky trick will help you as well. I hope this video has been useful for you. This video has been about using the vertex form and using completion of the square to get the vertex form and then finding 5 points in 2 different ways when our lead coefficient is not 1. Instead, -1 in one case and 2 in another case.